Warning, the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. This video is meant as a review of concepts from your trig class. As such, I do not delve into the proofs of theorems, nor do I go into excruciating detail with examples. If you've never had a full course in trigonometry and you are currently in a pre-calculus course, I highly recommend watching my trigonometry playlist on YouTube, as it goes into greater detail with all of trigonometry. Again, trig is so important for calculus that having a shaky background in the subject will lead to abysmal results in calculus. With that said, let's go into a review of graphs of the sine and cosine functions. So I normally would never start teaching this topic with a how-to, but it is assumed that you know how to do this. So you could pause and read through this. I'm actually just going to start into graphing. Just to let you know, well, maybe I will go into this, I guess. I take care of the mechanical stuff first. If somebody hands me a trig function, specifically in this case a sine or a cosine, of the form a cosine or sine of bx plus c plus d, I will state the amplitude, which is the absolute value of a. I'll state the period, which is 2 pi over b, state the step size, which is the period cut into 4 pieces, and state the phase shift, which is negative c over b. Oh, I also state the midline. And then I start graphing. All right, so we'll go ahead and just see how that works. But this is just a review of this, so I don't have a ton of examples. I think I only have 2. So you can read these directions here. I will say this, normally in a pre-calculus course, all these directions are implied. So they just, an instructor would just say, graph this function. It's implied that you will do all of the stuff listed here. So I read this from left to right. I make sure, first of all, that the trig function is stated first. In other words, authors love to write things like this, right? I dislike that form of it. I would prefer my function to be written first. And then I just read it from left to right. Well, maybe I start with just saying it's going to be a negative cosine. It's an upside down cosine function. And then I state the amplitude. The amplitude is just the absolute value of that negative 2, which is 2. I state the period of this oscillating function, which is 2 pi over b. So b in this case is 2/3. That's b. So 2 pi divided by 2/3, or in other words, 3 pi. I then want to state the step size because that helps me graph. If you've never used this method, it is a really nice method for graphing a single cycle of the trig function you're working with. It's the period over 4, so that's 3 pi over 4. Then I go to the next number, which is c, and I state the phase shift. And some people call that the horizontal shift, which it is, but that's not what c is. C is not the horizontal shift. C has something to do with the horizontal shift, but it is not the horizontal shift. The horizontal shift is negative c over b. So that would be negative pi over 6 over b, which is 2/3. So what is that? It's a positive 3 pi over 12, which is pi over 4. Let me just double check my mathematics there. Yep, pi over 4. That's my phase shift. And finally, the last piece, I didn't label A here, but there you go. Last piece is my vertical shift, which is 1. Now that I have that all listed out, I kind of go backwards. I start with the vertical shift when I start graphing. Let me go ahead and grab a ruler here. There we go. And I'll graph the midline. The midline, I usually just use a green line for it. The midline is where your the middle of your curve has been shifted to. It's your vertical shift, essentially. So our midline here is at a height of 1. We've lifted this graph up 1 unit. That's what the midline is. Then I graph the base function, negative cosine. So it's an upside down cosine. So I'll just, hopefully I get this somewhat nice. I'm going to pause so I can get it clean. That's somewhat clean. It's not the best in the world, but it is an upside down cosine function. And then, so I've done the vertical shift. I've dealt with that upside down cosine. Now I'm going to start at the phase shift because that will be my initial point. So my initial point on this horizontal green line, I'll label as the phase shift. The phase shift is a pi over 4. So here we go, pi over 4. That's where we're starting the graph. And then I will go by my step size. The step size will give me the key points. The key points are where it crosses the x-axis, where it reaches a maximum, where it crosses the x-axis again, and where it reaches a minimum. It's basically when it crosses the midline and when it attains its maximum and minimum values. The step size will get me to each of those. The step size is 3 pi over 4. So if we started at pi over 4 and you add a 3 pi over 4, you're now at 4 pi over 4. Add another 3 pi over 4, you're at 7 pi over 4. Add another 3 pi over 4, you're at a 10 pi over 4. Add yet another 3 pi over 4, and you're at 13 pi over 4. Notice the distance between beginning and end. Pi over 4 to 13 pi over 4. That's 12 pi over 4 or 3 pi. And that is actually the period of your function, so that works out. Once you're done with that, you climb that ladder, it's probably good, not just probably, it's definitely a good idea to graph your y-axis. So I'm going to graph that now in black, just like that. Here's the y-axis. And then label the y values. So I'm going to label these y values. Remember, the midline occurred at y equals 1. So this is a height of 1 right there. So the maximums and minimums occur the amplitude away. The amplitude is 2, so the maximum is going to be at 1 plus 2, which is 3, and 1 minus 2, which is a negative 1. Once you get that, you know where your x-axis is. It's halfway between a height of 1 and a height of negative 1. So the x-axis is probably right about here. And you have your entire graph. You obviously know it's not the entire graph. It goes on forever in both directions. So you could showcase that using dashed work here, just to tell your instructor that, yep, I know it goes on forever, but here's one really nice full cycle of the cosine function that you asked for. There you go. That is a review of graphing sine and cosine. Or at least the cosine. Let's go ahead and graph the sine. So again, the likelihood is in a pre-calculus course, you're not going to see all of these instructions, but it'll be assumed that you're going to do those instructions. So we have this sine function we're being asked to graph by hand. And there's a reason why you're graphing by hand. It's because it showcases that you know what your function looks like, that you can do your shifts and translations very quickly. So anyhow, we know it's a sine function. Its amplitude is the absolute value of 0.7, which is 0.7. The period is 2 pi over b. That's 2 pi over 3. The step size is the period over 4. So that's 2 pi over 3 over 4. Which would be pi over 6, I think. Looks about right. Let me see. Yep, that's right. And then the phase shift is negative c over b. I do usually write that out. So that's negative 7/3. And then finally, the vertical shift is a negative 2.3. It looks like these are ugly values, but I'm telling you, the amount of work you're going to be doing here is about the same as with the previous problem. Let me grab my ruler. I kind of left it down here. And let's go ahead and draw the midline. I'll kind of write it a little bit lower just because this has been shifted down 2.3 units. Let me move that off the screen there. So our midline is at y equals a negative 2.3. Our base graph is the sine curve. So I'm just going to chicken scratch out a sine curve. Let's see, this is the beginning, this is the end, this is halfway in between. It is a positive sign, so it goes up and then comes back down. All right, so let's go ahead and scratch these out, right? And this time I'm actually going to just leave the video running while I do this, just so you can see this is the level of exactness that I expect from my students. And let's see, so that vertical shift is done. We've graphed the sine. We start graphing at the phase shift. In other words, our key points start at a -7/3. That's where our key points start. And notice our step size. Our step size is a pi/6. That is, to get to the next point, that's a key point where you have a maximum, you're going to add pi/6 to -7/3. And to get to the next key point, you add another pi/6 and another and yet another. The problem with that is that adding pi/6 to -7/3 is a pain. So this is what I recommend to my students. If you're adding a 7 or a pi/6 to a -7/3, this is what you should get. Therefore, leave it like that. In the next step, you'll have another pi/6 that you're adding. So this is your second point, 2 steps of size pi/6. And the next point started at -7/3, and you have 3 steps of pi/6. And the next point was started at -7/3, but now it's 4 steps of pi/6 away. That's what I recommend doing if the units don't match up nicely. So we take care of the step. If you measure out the period on that, it is 2pi/3. I'm not going to bother. And now we're ready to draw in the y-axis. Now the weird thing here is that you're starting at a -7/3. It's a -2.3 and some change, obviously. And you need to know where the y-axis fits here. So you need to know which of these numbers that you're adding is greater than 2.3. So let's see, pi is roughly 3, so 2 pi, that's 6, so that's 1, maybe 2. This might be right around where the y-axis is actually. And in this case, I would probably grab a calculator just because I want to put the y-axis at the right spot. So 4 pi over 6 and then -7/3 is still negative actually. So the y-axis is just slightly to the right of that point. Kind of interesting. So I'm going to go ahead and put the y-axis slightly to the right of that. Here we go. There's the y-axis right there. And let's go ahead. I can just move that off the screen. We know the height of the midline is -2.3. But now we need to know where do the maximums occur as far as y values and where do the minimums occur as far as y values. Well, that's with the amplitude. You're going to add and subtract 0.7 from the y value of -2.3. If you add 0.7, you'll be at a -1.6. If you subtract 0.7, you'll be at a -3. And that will give you a pretty decent understanding of where the x-axis is. It's pretty far up here, maybe around here. So I'll draw in the x-axis. There it is, x, and I'll label my y. And that is pretty much done. Again, the same amount of work as the previous problem. There you go. So that is graphing the sine and cosine functions. And that's all we're doing in this review.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry. Don't